Have you ever looked at a star and wondered if the disaster already happened and we just have not seen it yet? Because one of the most famous lights in the sky is behaving like it is hiding a final secret. So before we open this cosmic mystery, tap like, subscribe, and share this with the one person who would absolutely walk outside tonight just to stare at Orion. Betelgeuse has always felt bigger than astronomy. It is not just another dot in the dark. It is the red star on Orion's shoulder, bright enough for ancient sky watchers, sailors, farmers, poets, and children to notice without any telescope at all. People have looked at it for thousands of years. They gave it names. They built stories around it. They tracked the seasons with it. And now, after all that time, we are learning that the star almost everyone recognizes is stranger, more violent, and more unstable than we thought. That is why the newest wave of observations has people so locked in. This is not one small update buried in an academic paper. This is a complete shift in the story. Infrared observations from powerful space telescopes, especially the James Webb era of astronomy, are letting scientists study the dust, heat, and material around Betelgeuse in ways older instruments never could. At the same time, other cutting-edge observations have exposed something astronomers chased for more than a century: a hidden companion star, tucked so close to Betelgeuse that it stayed invisible beside all that blazing light. And the moment you put those two things together, the entire picture changes. Because now the question is no longer just, is Betelgeuse dying? We already knew the answer to that. Massive stars like this do die. The real question is far more unsettling. What exactly is happening there right now? Why did this star suddenly dim so dramatically that the whole world thought it might explode? Why is its surface throwing material into space? Why is there a second object disturbing the gas around it? And are we watching the slow, chaotic buildup to one of the greatest sky events human beings could ever witness? To understand why that possibility is so gripping, you first have to understand what Betelgeuse actually is. Betelgeuse is a red supergiant. That label sounds technical, but what it really means is almost hard to accept. This star began its life far more massive than the Sun, and because of that mass, it burned through its fuel fast and violently. Stars do not live forever. They survive by balancing two forces. Gravity pulls inward, fusion pushes outward. As long as that balance holds, the star lives. But massive stars spend fuel recklessly. They burn brighter, they burn harder, and they burn out sooner. Betelgeuse is now in that late, unstable phase. It has expanded into a swollen giant, one of the largest stars you can see with the naked eye. If you placed it where our Sun is, it would not just swallow Mercury, Venus, Earth, and Mars. Its outer layers would reach out toward Jupiter. That is how enormous this thing is. It is not a star you compare to mountains, planets, or even normal stars. It is a system-sized furnace, a giant sphere of hot gas so huge that the mind almost refuses to picture it correctly. And yet, for all that size, Betelgeuse is not calm. It pulses. It changes brightness. Its outer layers rise and fall. Its surface is not smooth like a perfect ball. It churns. Giant cells of hot material rise from inside the star, cool and sink again, like boiling water in a pot, except each one can be larger than the Sun. So even before the recent headlines, Betelgeuse was already famous among astronomers for being alive in a very visible, very messy way. Then came the event that turned that quiet scientific fascination into global drama. In late 2019, Betelgeuse started fading. Not a little, not in some tiny way only experts could detect. It dimmed so strongly that even ordinary sky watchers noticed. A star that had held its place in the winter sky for generations suddenly looked wrong. By early 2020, it had lost more than half its visible brightness, eventually dropping by over 2/3 at its faintest point. For a moment, the internet, the media, and a huge part of the astronomy world all started asking the same question. Was this it? Was Betelgeuse about to explode? It was a reasonable fear. When a red supergiant reaches the end of its life, it does not fade politely into darkness. It dies in a supernova, a catastrophic collapse and explosion powerful enough to outshine entire galaxies for a brief time. If Betelgeuse were to go supernova, it would become one of the most spectacular sights in human history. It could shine in the daytime. It could blaze at night for months. People across Earth would walk outside and see a brilliant new beacon where a familiar red star used to be. So when Betelgeuse suddenly faded in a way nobody had seen before, the idea did not feel crazy. It felt possible. But that was not what happened. The star recovered. Its brightness slowly returned. The explosion never came. And that should have made the story less dramatic. Instead, it made the story more disturbing. Because when scientists dug into the data, they found something almost unbelievable. Betelgeuse had not dimmed because its core was obviously collapsing. It had dimmed because it appears to have blasted out an enormous amount of hot material from its own surface. That material moved away from the star, cooled, and formed dust. Then that dust drifted in front of part of Betelgeuse from our point of view, blocking some of its light. Think about how bizarre that is. The star effectively made its own curtain. NASA's Hubble observations pointed to a huge outflow of dense, heated material moving through the star's atmosphere at extreme speed. Researchers traced a timeline in which a bright, hot region on the star pushed outward, and then later, a large section of the star's visible face dimmed as dust formed farther out. In simple words, Betelgeuse seems to have thrown off part of itself, and the debris temporarily hid the star from us. That alone would have been enough to keep astronomers busy for years, but Betelgeuse was not done. As researchers kept studying its behavior, an older mystery returned to the center of the story. Betelgeuse had long shown more than one rhythm in its brightness. There is a shorter pulse, roughly a little over a year, that fits the idea of the star expanding and contracting, but there is also a longer cycle, around 6 years, and that one never sat comfortably inside the usual explanation. Something else seemed to be involved. For years, some astronomers suspected a companion star, a smaller star, a hidden partner, something orbiting close enough to affect Betelgeuse's outer layers. The problem was simple and cruel. Betelgeuse is so bright that seeing anything right next to it is like trying to spot a spark floating beside a floodlight. If the companion existed, Betelgeuse itself was hiding it. So the idea stayed alive, but it remained unproven. That changed when newer observations finally caught what people had been hunting for. Using high-resolution imaging and precise predictions from long-term data, astronomers managed to detect the likely companion star at the exact kind of moment they had hoped for, when its separation from Betelgeuse made it easiest to see. Later reports from major observatories and NASA-backed teams strengthened the case. A star really does seem to be there. Not a planet, not a glitch, a stellar companion, a real object orbiting one of the most famous stars in the sky. And that discovery matters for a reason bigger than the shock of finding a hidden star. It may explain behavior that never made sense before. If a companion is orbiting deep inside or near Betelgeuse's extended outer atmosphere, then it is not just passively sitting nearby. It is moving through gas. It is stirring material. It is shaping the environment. Recent Hubble-based work even found evidence of a dense wake trailing through Betelgeuse's atmosphere, like the ripple behind a boat moving through water. That means the companion is not just present, it is interacting. That is huge. It means Betelgeuse is not a lone giant slowly dying in isolation. It is part of a close, messy relationship, and in astronomy, close relationships can get violent. A companion star can disturb gas, affect how material is lost, influence what we see from Earth, and help explain repeating patterns. It may even play some role in triggering or amplifying the kinds of disturbances that made Betelgeuse erupt and dim so dramatically. Scientists are still being cautious here, and they should be. Nobody honest is saying, case closed, the companion caused everything. But for the first time, that question has teeth. And this is where James Webb becomes such a powerful part of the story. Webb does not just take pretty pictures, it sees the universe in infrared, which means it can study heat and look through regions of dust that block visible light. That is exactly the kind of power you want when you're dealing with a dusty, unstable red supergiant. Betelgeuse is wrapped in its own history, shells of gas, clouds of dust, ejected matter from earlier outbursts. Visible light can be confused or blocked by all of that. Infrared can cut deeper. That is why new images and observations in the Webb era feel so important. They do not just show a star. They help scientists read the environment around the star. They reveal structure in the dust. They expose temperature differences. They let astronomers study how matter is moving, cooling, and spreading after it leaves the surface. They make Betelgeuse feel less like a distant point of light and more like a living system in motion. And once you see Betelgeuse that way, the whole emotional weight of the story changes. This is not just a dying star. It is a star actively shedding itself. Every layer it loses is a clue. Every dust cloud is a record. Every pulse and brightness is a message from a place human beings will never physically reach. We are learning to read those messages almost in real time. If you are still with me, hit like, subscribe, and pass this video to someone who loves big mysteries. Because the deeper we go, the stranger this star gets. One of the most fascinating parts of this story is cosmic timing. On one hand, Betelgeuse is unimaginably far away. The light we see from it tonight left the star roughly 650 years ago. That means every image, every brightness change, every strange pulse we record is history arriving late. We are not watching Betelgeuse live in the way we watch a storm outside our window. We are watching delayed truth, medieval light, ancient signals reaching modern instruments. On the other hand, our tools have never been better. We are living in the era when telescopes can finally do more than merely notice that Betelgeuse exists. Hubble can monitor its outer atmosphere. Ground-based systems can separate nearby light sources with shocking precision, and Webb can examine the infrared structure of dust and gas that older astronomy would have struggled to interpret. So there is this eerie overlap. The star is sending us old news, but we are receiving it with brand new eyes. That overlap is what makes this moment feel special. For thousands of years, Betelgeuse was a red point in a pattern. Then, in just a few decades, it became a surface with motion. Then a star with eruptions. Then a star with a possible hidden companion. Then a star whose companion seems to leave a wake inside its atmosphere. Then a star whose dust and expelled material can be studied with far greater depth than ever before. It is like a character in a story who suddenly starts speaking after being silent for ages. And what Betelgeuse is saying is not comforting. The star is unstable. It is losing mass. Its brightness changes are not trivial. Its atmosphere is enormous and disturbed. It has already produced one dramatic dimming event that forced astronomers to rethink their assumptions. And because it is a red supergiant, every new sign of instability automatically raises the same beautiful possibility. What if the ending is getting closer? Now, I want to be careful here, because YouTube videos often go wild. Betelgeuse could explode tomorrow. Betelgeuse could also explode tens of thousands of years from now. Both statements can exist side by side, and that sounds ridiculous until you understand the scale of the problem. In cosmic terms, Betelgeuse is absolutely near the end of its life. In human terms, near the end can still mean a very long time. Astronomers cannot open the star like a machine and read a countdown clock inside it. They infer, compare, model, and observe. So when people say Betelgeuse is dying, that is true. When they say nobody knows exactly when it will explode, that is also true. But uncertainty does not make the story smaller. It makes it more haunting. Because if Betelgeuse did collapse right now, we would not know tonight, or tomorrow, or next year. Its supernova light would still be on the way. The sky can keep secrets simply because distance delays the message. That idea is hard to shake once it lands in your mind. Somewhere between fear and awe, a strange thought appears. The greatest sky event in human history might already have happened, and we could still be waiting for the light. Again, that is not a prediction. It is a reminder of how space works. And it is also a reminder of why scientists care so much about studying this star before the final blast ever comes. A nearby supernova would be a scientific treasure beyond almost anything we can imagine. Betelgeuse is close enough to be watched in extraordinary detail, but far enough away that it poses no danger to Earth. That is the ideal combination. We would get the spectacle without the threat. The explosion would flood astronomy with data about how massive stars die and what they eject, how shock waves move through stellar material, how dust behaves under extreme conditions, and what is left behind in the core. Maybe a neutron star. Maybe more clues than we have ever had from a nearby supernova. Maybe answers to questions astronomers have been asking for generations. And the reason Webb matters so much is simple. Betelgeuse is dusty. Its own material surrounds it. Visible light can be affected by that dust. Infrared can tell a cleaner, deeper story. Webb would be able to observe features of the event that older systems might miss. In other words, if Betelgeuse explodes during the lifetime of these modern observatories, humanity will not just witness it. Humanity will study it in a way no past civilization ever could. That is why the phrase, new images, matters. This is not just about seeing a star more clearly. It is about building a record before the climax. It is about watching a long, unstable process unfold step by step. It is about catching the fingerprints of physics in the dust, gas, motion, and light before the final page turns. There's also something deeply emotional hidden inside all this science. Betelgeuse has always felt personal. You do not need a degree to find it. You do not need expensive gear. Go outside on a winter night, look at Orion, and there it is. That familiarity tricks us into thinking it is simple. Familiar things feel knowable, but Betelgeuse is not knowable in the ordinary sense. It is a giant sphere of plasma, hundreds of times larger than the sun, wobbling and heaving and coughing material into space while a smaller star circles near it. The more we learn, the less ordinary it feels. Familiarity fades, and in its place comes wonder. Maybe that is why the great dimming hit people so hard. It was not only science, it was psychological. Imagine how strange that is. Most people go through life assuming the night sky is stable. Constellations feel permanent, stars feel fixed. Then one of the brightest stars changes enough for millions to notice, and the universe feels living. That moment mattered because it broke the illusion of stillness. And now, with the companion star story growing stronger, that break becomes even more dramatic. Betelgeuse was not just dimming. It may have been acting inside a system more complicated than we knew. A giant, unstable star, a hidden partner, gas disturbances, dust clouds, pulsations, heat, mass loss, a possible wake cutting through the atmosphere. This is not a single clean mystery. It is multiple mysteries stacked together. And that kind of complexity is exactly what keeps astronomers obsessed. Because whenever the universe gets messy, it usually means the underlying physics is rich. Take the wake idea, for example. The fact that scientists can infer a wake caused by the companion is incredible. It means this is not just a binary star in the simple textbook sense. This is a binary system where one star is huge. One star is so huge and puffed up that the other can influence material around it in a visible way. That gives us a front row seat to processes that may matter for how giant stars lose mass before they die. And mass loss is not some tiny detail. It shapes the final explosion, the remnant, and the material scattered into space. So yes, this is a story about a famous star. But it is also a story about how stars enrich the universe. When red supergiants die, they do not vanish. They release heavy elements into space. Those elements later become part of new stars, new planets, and eventually, in some cases, living things. In a very real sense, the death of stars helps build the future. Betelgeuse is part of the long chain of cosmic evolution. That does not make its fate less dramatic. It makes it more meaningful. If you wonder whether observations mean we solved Betelgeuse, the answer is no, not even close. They have better evidence, better images, and better models. But Betelgeuse still refuses to become simple. Every answer reveals another layer. The Great Dimming got an explanation, but it also raised deeper questions. The companion star idea got stronger, but that opened new questions about influence, orbit, and long-term evolution. In other words, Betelgeuse is not a solved mystery. It is an active one. And active mysteries are the most powerful kind, because they make you feel like the next observation might matter. All of it could shift the story again. If this star pulled you in, subscribe and drop this video into your group chat. Let me know in the comments whether you think Betelgeuse has already exploded and we're just waiting for the light. Now let us talk about the image problem, because people misunderstand what seeing means in modern astronomy. Telescopes like Webb are not taking ordinary snapshots. They are collecting light far beyond human vision, turning that data into images scientists can analyze. That is why an infrared image can reveal truths a visible one misses. With Betelgeuse, that matters enormously because the star is wrapped in dust and constantly changing material. Put the versions together, and the star stops looking like a lamp and starts looking like a weather system made of fire. That is the emotional power of Webb's role here. It is not merely showing us beauty, it is revealing vulnerability. When astronomers study Betelgeuse in infrared, they can follow the heat signatures of matter leaving the star. They can inspect the environment where future changes will unfold. They can see the star not as a symbol, but as a process. And process is the key word. Because Betelgeuse is not waiting politely to die. It is actively changing while we watch. It is pulsing, shedding, disturbing its own surroundings, interacting with a companion, rewriting old assumptions. That is why these observations feel urgent. The story is already happening now. Right now, every shell of dust around it is preserving a past event. Every brightness fluctuation is a pattern. Observatories on Earth and in space are piecing together a biography written in light. That biography is wild. It tells us that what looked like a simple point of red light is actually a scene of ongoing violence. For me, one of the most humbling parts is how recently we became capable of understanding any of it. Think about how many winter nights Betelgeuse has shone over camps, cities, deserts, ships, fields, and rooftops. Then we watched it dim in a way that frightened the whole world. Then we found evidence that it may not be alone. That progression is astonishing. We live in a thin slice of time when an old light is giving up its secrets. Not all of them, but enough to make the sky feel new again. People are hungry for moments that make the universe immediate. Betelgeuse is close enough to know by name, famous enough to matter, and mysterious enough that every image feels like a message. So where does that leave us? It leaves us in a strange and beautiful position. We know Betelgeuse will die. We now have strong evidence that a hidden companion star is involved in shaping parts of the system's behavior. Every new observation matters because it helps us understand what the last chapter of a massive star looks like. But the deeper reason it stays with you is more human. You are looking at something temporary disguised as eternal. That red point seems fixed. It seems permanent. But it is not. It is a brief stage in a violent life. It is changing. It is shedding itself. It is moving toward an end. And somehow we have become smart enough to notice. That may be the most incredible part. Not just that it is unstable, but that a species on a small planet built tools to see it. We understand that the bright red star in Orion is not a symbol, but a real place, in crisis, evolving across centuries. And if one night that familiar red spark suddenly ignites into something so bright the world stops, we will be ready. People will not be staring at a random miracle. They will be witnessing the final flash of a story humanity learned to read. And that is why Betelgeuse matters. It reminds us that the sky is alive and the oldest lights can still surprise us. If this made you look at Orion differently, like the video, and share it with someone who needs a reminder of wonder. The next time you see that red star on Orion's shoulder, do not just call it beautiful, call it unfinished.